Good evening, sir. My name is Rajat Kadian, and I am sharing over my project to you. The overview of my dataset. The ransomware Bitcoin dataset contains information related to ransomware attacks and Bitcoin transaction. Ransomware is a type of malware that encrypts victim files and demands ransom payments in Bitcoin for decryption. The dataset includes features such as length, weight, income, and neighbors. Now moving forward with my model, first we load the model, drop the unnecessary column and dividing income by 100 million because in the dataset we have the value in Satoshi and 1 Bitcoin equal to 100 million Satoshi. So to convert values into Bitcoin, we are dividing it by 100 million. Now checking at the unique labels, white means the non-fraudulent transaction and all other are ransom family groups. If we talk about why I want to work with this dataset, working with this dataset is important for understanding the characteristics and patterns of ransomware attacks involving cryptocurrency payments. Analyzing this data can provide some valuable insights into the behavior of ransomware operators and their financial transactions, aiding in developing strategies for detecting and mitigating ransomware attacks in the future. Now performing EDA, we can see that for income of each label, non-fraudulent transaction has the highest income. If we talk about objectives and hypothesis, we can say that the objective of the machine learning implementation is to develop a model that can easily classify the likelihood of ransomware attacks based on specific characteristics of Bitcoin transactions. The hypothesis is that certain transaction features, such as amount transferred and the destination, might exhibit distinct patterns specific to ransomware attacks. By training a machine learning model on this dataset, the goal is to identify these patterns and build a classifier, now making values into dummy values, scaling the values so that we have 90% variance ratio. Now finding PCA, which have variance ratio greater than or equal to 90%. So no more data are lost. Calculating the SSE, we can find the elbow. From the elbow, we get that we need number of clusters equal to 2. Now applying three clustering models, k-means, agglometric, and dbscan. Creating a pipeline which is using feature scaling first, then PCA, and then clustering. By implementing this and checking the score, we selected agglomerative clustering. By selecting it, we can further see the statistics of the data. And now look at the tax pattern. Class 1's mean not fraud transaction and class 0 is fraudulent transactions. Plotting pie chart to understand the behavior and patterns. As we look in the pie chart, we can see that class 0 is using more weight, more length, and the most important, they uses the more number of loop transaction. So we can say that fraud transaction has a specific patterns. They use more number of loop transaction, less income, more length, and more weight. Now implementing classification. Looking at certain stats for class 0 and class 1. Then preparing features and targets. Using a grid search CV to find best hyperparameters for SVM, support vector machine. But this is a very exhaustive search, so I am just commenting it out for now due to lack of time in the video presentation. Now performing train test splitting, we created a list of all types classifier, implementing the classifiers, and then Summarizing their scores, we can see that Cat Boost performed the best in the score, now performing the pipeline according to the Cat Boost classifier. If we look at the confusion matrix, it also performed good. We can see the differences between actual and predicted, true positive and true negative values. Now creating ROC curve, we can see that we get a very good area for classifier around 94. Looking at the classification report, for class 1, we have precision of 82 and class 1 has 90, which is very good. Now, looking at the sample data, we created sample data from the mean of both the classes. Now, looking at the first sample data, we can see that we get the value. This group belong to a class 1, which means they are white transaction, no fraudulent. If we look at the another, it said this class belong to class 0, which means they are fraud transaction and dangerous groups. Their attack patterns are higher values for length, weight, count, loop, and neighbors. I also tried one neural networks with hidden layers to check the accuracy and compare with my classifiers. Here I also get a good accuracy of 80%, but Cat Boost still perform better. Now something about outside the project. I always wanted to integrate machine learning models with the web development so the non-technical guys can also use these models to classify something. So I created a Flask server, created a API with a post on it. And also I created a React app where I am using it. This is my React app. When I start it, I click on get prediction. Here I get the prediction results. These groups belong to class 0. They are likely fraud transaction and dangerous group. This is not a part of project, but just to integrate it, I performed this. Thank you so much. Have a great day.